So today's thing, what you're going to see it of Abina, erosion with the grayscale. So we'll have erosion of F by a flat structuring element B. So at the location X comma Y, which is defined as the minimum value of the image in the region. So which will be coincides with the B when the origin of B is at X comma Y. Okay. So that is the equations I have shown over on it. So how we'll be having of an erosion of F by a flat structuring element. அதே மாதிரி நான் flat structuring element எப்படி இருக்கும் அப்படிங்கிறதையும் நான் கொடுத்துருக்கேன். That is which shows that we'll have a extra element that is to be the bn of s comma t over on it. Okay. And when we are saying about the next thing, so actually this is the diagram which shows the structuring element. So on the structuring element la எப்படி இருக்கு அப்படிங்கிறது காமிச்சு. Okay. So general effect of performing an erosion in the grayscale images வந்து பார்த்தோம் அப்படின்னா, if all the images of the structuring element are positive, so output image tends to be a darker than the input image. Okay. So the effect of bright details in the input image வந்து பார்த்தோம்னா, which will be smaller in area. So then the structuring element is reduced. So with the degree of reduction வந்து will be determined by the grayscale values surrounding by the bright beam and by shape and amplitude values of the structuring element itself. Okay. So whereas the case of a dilation of a grayscale பார்த்தோம் அப்படின்னா, similarly we can able to define for the dilation for the flat structuring element B and non-flat structuring element. Okay. And when we are seeing up that, which is defined as the maximum value of the image in the region, which is outlined by B over on it. So dilation of F வந்து non-flat structuring elementsல அங்க மைனஸ்ல பார்த்தோம் இல்லையா. So here we'll be seeing with the positive element of Bn. So general effects பார்த்தோம் அப்படின்னா, அதாவது if the values of structural elements வந்து are positive, so output images வந்து என்ன ஆகும்னா, which tends to be brighter than the input. So dark details வந்து will be reduced or eliminated. So depending on how their values and shape வந்து பார்த்தோம்னா, which is related to the structuring element, which is used for dilation. Okay. So when we are having a grayscale, the thing has to be that, so we'll have a dilation simple function. So a structuring element of A height A பண்ணுவோம். So அதோட dilation for various positions இருக்கும் நமக்கு. So complete result of dilation that I have shown over here. So dilation and erosion grayscale imagesல பார்த்தோம் அப்படின்னா, that is we'll have a complementations and reflections over on it. Okay. And similarly we'll be having about an opening and the closing. So the thing is to be that opening la we have to remove the small light details. Similarly for the closing of grayscale images we have to remove the small dark details. This is which is undisturbed overall gray levels and large bright features. Okay. So opening and picture வந்து பார்த்தோம் அப்படின்னா, which is the pushing object B, which is under the scan line graph while traversing the graph according to the curvature of B over on it. Okay. So peaks வந்து usually it will be remaining in the original form. The morphological reconstructions வந்து which involves the two images and structural emergence. So we have a two images on the marker F starting point for transformation, mask G வந்து which is constrains the transformation. So some applications of grayscale morphology பார்த்தோம் அப்படின்னா, we'll have a morphological smoothing, morphological gradient, top hat and bottom hat transformation, textural segmentation, and the granulometry. So morphological smoothing, in the sense it will perform the opening followed by a closing. So net result of these two operations வந்து பார்த்தோம் அப்படின்னா, is to remove or attenuate both bright and dark artifacts or noise. Whereas the case of a morphological gradient வந்து, we'll have a dilation and erosion. They are used to compute the morphological gradient of an image. So which is used to highlight sharp gray level transitions in the output images over on it. So we'll have a symmetrical structuring elements which tends to depend less on earth direction. So some of the morphological applications, what I shown over here, morphological smoothing, morphological gradient, and we'll have a top hat transformation, which is also called as white top hat. So which is detect structures of a certain size. So we'll have a light objects on a dark background. Whereas the case of a bottom hat transformation பார்த்தோம் அப்படின்னா, that is also called as black top hat. It detects structures of a certain size இருக்கும். We'll have a dark objects on a bright background இருக்கும். So some applications, so the top hat transformation or bottom hat transformation எப்படி இருக்கும் அப்படிங்கிற மாதிரி I shown figure over here. And the remaining applications will have a textural segmentation. So objective வந்து பார்த்தோம் அப்படின்னா, which is used to find the boundary between the different image regions, which is based on the textual content. So similarly, it will performing the closing with successive larger restructuring element till removing the small blocks. So it will perform simple opening and it has to perform simple thresholding. Okay, and the final thing what we have over on it abdina, granulometry. So in the case of an granulometry, which is a field that deals principally with the determining the size, the distributions of particles in an image. So because the particles வந்து பார்த்தோம் அப்படின்னா they are lighter than the background, so we can use a morphological approach to determine size distributions, and it is used to construct at the end of a histogram of it. Okay, so based on the idea என்ன பண்ணுவோம் அப்படின்னா, the opening operations of a particular size வந்து which have the most effect on regions of the input image that contains particles of similar size. So this type of processing is useful for describing regions with the predominant particle like character. The remaining thing that we can see in the next class. Thank you all.